Hi, this is an invitation to engineers and technocrats from data-driven learning to knowledge-driven intelligence. I'm Dr. Ravi Shankar Polisetti, a pediatric cardiac surgeon by training and a clinician scientist by practice. Over the past 3 decades, my work has extended beyond surgery into naturopathy, translational Ayurveda, and integrative clinical systems with a singular focus, improving outcomes in end-stage disease where conventional pathways have been exhausted. In the process, I encountered a fundamental limitation, not of medicine alone, but of modern artificial intelligence and data science itself. The core problem with current AI and ML. Most modern machine learning systems, whether based on CNNs or RCNNs, transformers, or deep representation learning, are statistically powerful but epistemically shallow. They rely heavily on massive label datasets, brute force feature extraction, deep hidden layer abstraction, correlation driven learning rather than causality. In domains like medicine, especially translational medicine, involving complex biological systems, this approach leads for extremely high sample complexity, long convergent timelines, poor interpretability, fragile generalizations across cohorts, the black box decision boundaries with limited clinical trust. If one were to apply pure data-driven deep learning to dominate domains such as Ayurveda, TCM, or even complex physiological regulation, one would require hundreds of latent layers, millions of samples, decades of real-world data accumulation. In practical terms, this would mean at least 80 to 100 years of iteration to reach clinically usable intelligence. Instead of forcing machine learning to discover biological structure from the scratch, we took a radically different approach. And about 3 decades ago, we experimentally modeled biological states, especially the Vata, Pitta, and the Kapha, using controlled experimental animal models. These were not metaphors or philosophical abstractions, but quantifiable physiological, metabolic, inflammatory, and neuroregulatory states. From these models, we derived deterministic rule sets, causal constraints, straight transition logic, boundary conditions, and priors. This resulted in construction of rule-based engines, formalized, interpretable, and grounded in biological reality. These engines were implemented using OOP, object-oriented programming paradigms, modular state machines, rule-driven inference layers, deterministic decision trees with bounded uncertainty. Hybrid intelligent rules plus machine learning was derived only after encoding domain intelligence did we apply machine learning. In this architecture, ML does not perform blind feature extraction. ML operates on top of a structured rule-based representations. Feature spaces are constrained by domain knowledge. Learning occurs within biologically meaningful manifolds. This dramatically reduces sample complexity, training time, model brittleness, overfitting risk. What would traditionally take several decades or even centuries, if I might say so, of brute force deep learning, we achieved in a fraction of time through translational knowledge engineering. This is not symbolic AI, friends. This is not classical expert systems. This is hybrid intelligence, a synthesis of knowledge-driven systems, rule-based reasoning, probabilistic learning, modern ML optimization. Why this matters for engineers and data scientists. The future of AI, especially in healthcare, biology, and complex systems, will not be won by deeper networks alone. It will be led by those who can encode domain knowledge into algorithms, design interpretable AI systems, combine casual reasoning with statistical learning, build AI that converges faster, generalizes better, and earns trust. This course exists to train a new class of data scientists from India, engineers who can operate 30 to 35 years ahead of conventional ML curricula, friends. You will learn rule-based system design for complex domains, knowledge-augmented machine learning, translational modeling from biology to software, object-oriented AI architectures, hybrid inference systems, clinically interpretable AI pipelines, and you see a strategic advantage for the next generation. Most global AI education focuses on libraries, frameworks, benchmark performance. I-PRISM focuses on thinking. By the time conventional ML reaches similar levels of domain intelligence through brute force data accumulation, those trained here will already be designing architectures, leading research, building platforms, shaping policy and standards. This is not a course in learning algorithms. This is a course in building intelligence. And before you enroll, if your goal is to understand AI behind APIs, build systems that reason and not just predict, work at the intersection of medicine, biology, and computation, create globally relevant, defensible AI architectures, then this course is for you. If you believe intelligence begins only with data, this course will challenge you. If you believe intelligence begins with understanding, this course will empower you. Welcome to I-PRISM.
The I-PRISM Civil Engineering stream empowers engineers to design the sustainable, smart, and resilient healthcare infrastructure of tomorrow. Students learn how human physiology interacts with built environments, how airflow, lighting, acoustics, materials, and spatial design influence healing, immunity, and recovery. You will design clinics that reduce infection spread, optimize ventilation, and align lighting with circadian rhythms to actively support patient health. The program integrates regenerative therapy infrastructure, clean room standards, herbal pharmacy design, medicinal landscapes, and toxin-free building systems. You'll explore digital health architecture, telemedicine pods, IoT-enabled monitoring rooms, AI-driven patient flow optimization, and data-secure facility layouts. From meditation zones and biophilic interiors to high-tech diagnostic suites and regenerative therapy blocks, you will create spaces that merge engineering, medicine, and sustainability. This is not just construction. This is building the future of healing environments.